Which of the following expressions is equivalent to x squared minus 2x minus 5 over x minus 3? Okay, so normally when I look at a problem like this, I go through thoughts that go like this. I'm like, oh man, I can't wait for something like this to happen. Well, that's not going to happen. How do I know that's not going to happen? Because look at the answers that I have. So what I'm going to do is I'm going to use the good old-fashioned long division method of dividing polynomials. Although you can use synthetic. So why don't I do this? I'm going to make an extra long video and I'm going to show you how to do this using long division. And I'm going to remind you how to do this using synthetic. And the four of you who watch these videos can figure out which one you like best. So this is the long division way of doing it. All right, I'm going to set it up. X minus 3. Make sure that that's in standard form. Make sure nothing in the middle is missing. X squared minus 2x minus 5. Just like regular long division, you ask yourself, x times what gives me x squared? Well, x times x gives me x squared. Take that x and multiply it to this whole factor right here. X times x is x squared. That'll always happen. X times negative 3x, or negative 3 is negative 3x. Now you subtract this entire chunk right here. And when you subtract the entire chunk, you flip the signs of everything. So you go away. Negative 2x plus 3x is regular 1x. Repeat. X times what is x? 1. Take that 1 and multiply it to this whole thing right here. Okay, although also, and I should have done this earlier, shame on me, I needed to drop down to minus 5. That'll help. That'll help a lot. All right, 1 times x is x. 1 times negative 3 is 3. Now I have to subtract this entire x minus 3, which requires me to flip the signs. And that gives me a remainder of negative 2. Now, when you have a remainder of negative 2, you take that, make it a denominator of a fraction. Make that a numerator of a fraction whose denominator is the factor. So if I were to write all this out, x plus 1, let's bring the negative out front, minus 2 over x minus 3. The answer is D. Now that's long division. Okay, that's polynomial long division. All right, usually we don't have to do that because the numbers are nice enough, and I showed you where if I had parentheses and things crossed out, life would be easy. And if it was that easy, if that was the case, you get a remainder of 0 and you wouldn't have to worry about all this mess. Well, we had to worry about it. And the other way of doing this could be synthetic division. Now, how do you do synthetic division? Let's set it up. It's been a while for me, but I like synthetic. Okay. In here, the numbers that you're going to put on this large-looking L thing are going to be the coefficients of what you have up here. So the 1, negative 2, and negative 5. What you have in this little box here is going to be the root that you're going to use. The root that we're going to use is going to be the opposite of that guy right there, which is positive 3. Step number 1 is always drop down the 1. 3 times 1 is 3. Put it right there. Add these guys. Negative 2 plus 3 is 1. 3 times 1 is 3. Drop down the negative 2. Now, what's 1 remainder of negative 2 means? Well, if you have a remainder of negative 2 is going to live in the numerator, and in the denominator is going to be your original factor, just like last time. What about that 1 and that 1? You work your way left, okay? Attach nothing. attach an x. And then if you were to keep going, attach an x squared, attach an x cubed, blah, 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 blah. Cleaning this up, I don't need that 1 anymore. That 1 is still a 1. Bring out that negative 2 over x minus 3. So a little double whammy for you. A little synthetic, a little long division. Lots and lots and lots of fun. Either way, we got the same answer. And that answer was D. D for delightful.